Now we will discuss this A-star algorithm. Our A-star algorithm consists of three main functions or three functions in the entire program. And if you take a look at it, it is a dictionary of list. And again, inside the list, we are having a tuples. So just we are going to represent our graph in this way. We are using this graph node dictionary. Okay, the next very first line we are having is a star algo of a comma G, where A is our start and G is our stop. Means goal node. A is our initial node and G is our goal node. We'll just go and check with our function definition what it is having. Okay, start node and stop node. So those have been considered as start node and stop node. So what is now a start node? Start node is A and stop node is G. Okay. Now the very first line inside our function definition we are having is a open set. Open set equals to set of start node, which is nothing but now inside this it will be having storing open set consists of a set, and this inside set it will be storing a you remember that, and close set is a set which is empty. Right now we are not having any value. Now a G is also one dictionary, it is not a set, we are having a dictionary. Now we'll be having, for those who don't have the idea about A star algorithm, I kindly request everybody to understand first the working of the A star algorithm, then go looking at this program. Usually we'll be having a priority queue data structure we are using here to store the open list and close list uh, once for after opening that, and we are going to move that into the closed list. So the working of the A star algorithm, you just go through and have a look. Okay, now this parent is also one dictionary, and G of start node. What is G of start node? G of start node is nothing but A. G of A, we are having a value as assigned as 0. Now parents of start node, that is parent of start node A equals to A itself. So we are going to assign this A equals to A right now. So the next very line is while length of open set. What is open set we are having? In open set we are having the length of this, it will become 1. So 1 greater than 0, so it will enter into this while loop. Inside this while loop we are having n small n equals to none. It is assigned to small n equals to none. Okay, for v in open set, so open set is the only one value that we are having, that is a. Now v is holding a. If n, what is that n? N is none. We have declared that n is none, and or g of v plus heuristic of v less than or g of n plus heuristic of n. It is not checked because it is a logical or. If it is a logical or, if the first statement is true, the second statement it won't consider. So here we are going to assign n equals to, what is that means n now will be holding the value of, that is right now n is having a value of a. So how the a value game is, here v is a, so n is assigned to a. Okay, now is n is none? No, n is a, so it won't execute this block. Now if n equals to stop node, what was our stop node, that is g, it is not also, it is also not executed this particular block. Now I just erase this one. Now where it goes means it will come to here our for loop, it will come to our for loop. So what is this for loop is actually iterating get node. What is this? Get node is a function call. What is a function call? This is a function call. Get node of what? N. N is nothing but now A. So get node of A, or get neighbors. Sorry, get neighbors of A. Get neighbors of A. If we in graph nodes. So what is this graph nodes? If you see this graph nodes, it is a dictionary of list where internally you are having a tuples also, right? The graph nodes of A is there, V is nothing but A. So if A in graph nodes, yes, A is present inside the graph node. So graph nodes of graph node of V, it is going to call. So what happens here? Graph node of V, so graph node of A. So these values, that is b comma 2 and e comma 3, are being uh, written to wherever our get neighbors has been called. So here our values have been written. That is B comma 2, B comma 2, and one more. I'll just check that is E comma 3 or C comma 3. So E comma 3. So these values are written here. B comma 2 and E comma 3. B comma 2 and E comma 3 are written. This will be right now. This for loop will be holding the current value as B equals, that is M is B and weight is 2. Okay, for the first iteration, while this get neighbor function has been called in a for loop, this will return these values, and for the first iteration for loop, M will be holding the value B and the weight is 2. What is happening? If M is not in the open list and M is not in the closed list. Yes, it is true. Why? Because in open list there was only one element, that is A, and we are not having B and A and also E. So this condition will be true. Open set we are not having B, and this is logical. And the first thing that you have to check that if M not in open list and M is not in closed list. So either it should be true in the both cases, then only it will be executed. But here we can guarantee that, or we know that open set and closed set we are not having both B. So it will enter inside this if block. Now inside this if block, open set dot add M. So we are going to add a M. What is that M? M is nothing but our B. So we are going to add into open set our B. After that, we are going to add our parent. What is M? M is nothing but B and N is nothing but A. Parent of B we are going to get as A. Right? Again, G of B equals to G of A plus what was the weight it is carrying? It is 2. So G of N is nothing but 0. If you are having doubt, scroll up and it will be having G value. G of A is nothing but 0 over here because it is a start node. So our G of B will become 2. So you remember this one. Now the loop is not terminated. Still we are having value. What is the value that we are having means? That is we are having this value is been completed. Now for this E, now M will become E, weight will become 3, weight will become 3, and this if block will be executed. If E not in open set and E, B, sorry, E not in closed set. Yes, both the conditions are true. This if block will be executed. I'll erase this, you remember. So both conditions, that is both conditions are satisfying. So open set dot add. What is now M? M is nothing but now E. So E is adding in our open set. After that, parent of E will be given as N is nothing but A. N is not changed. Okay. Now G of E, G of E, the M is nothing but E. G of E is nothing but G of A means 0. G of A means 0 plus what was the weight? Weight of E was 3. So G of E will be 3. Okay. This is how we are going to execute this if block, and this for loop will be get terminated because the values of B comma E has been explored. So B and E are explored, or it is going to store. So this for loop will become terminated. Now this control flow comes over here. What is that? Open set dot remove of N. What is that N? N is nothing but A. So since A childrens are explored, so we are going to remove A from the open set and we are going to add that A into closed set. Okay, that is how it is done. Now there is one more thing, that whether our while loop has become false or not. Means is that everything has explored? No, because this while loop length of open set greater than 0. Initially it was A, so it was 1. Now our open set has added the values of what? B, comma, E. These are the values that we are having inside our open set. So now length it will become 2, 2 greater than 0. Yes, it is true. Now N is actually having none value. Again N is none now. Now for V in open set. What is V here? Inside this open set, B is there first. Now V will become B if n is none. Yes, n is none, or g of a plus rest of the thing it won't check. Now n will be assigned to is assigned to B. If n is none, yes, that is if n is none, is that true? No, n is right now assigned to B, so it won't execute. And n is not equals to stop node, and it is also not executed. Now it will directly come with the for loop. It will directly come for loop. It will directly come with for loop. So what is the for loop now holding? Get neighbors of n is right now. The for loop is right now executed for get neighbors of B. Get neighbors of B. Now if you check this get neighbors function, just check this one get neighbors function what we are having. Get neighbors of graph nodes is there. We are having graph nodes. In graph nodes B is there, right? B is there, and this B is having values C and G. So these C and G values will be returned to our function call, that is here get neighbors. Now get neighbors will be holding the values of sorry, I'll just have a look at it. So C and G, C1, G9, C1 and G9. So C1 and G9 values will be having in our get neighbors is returning C1 and G9. C1 and G9 values will be having in our get neighbor. Now the first iteration will be given for MSC and weight as 1. Okay. Now if M not in the open set and M not in the closed set. Yes, every C is present already in the open set. No, it is not present. And G is present. No, it is not. So this block will be executed. What it will executed? Open set dot add. What it is going to add? Add M, that is nothing but C. The parent of C is nothing but B. It is going to make as B. And the G of M is nothing but uh, G of C equals to G of B. Now G of B plus weight. What is the weight? It is going to carry 1. So it will calculate and it will be stored in the G of M. That is G of C. It will be stored.